Okay, so this week we're going to begin solving quadratic equations, which is really just an application of what we did with factoring. So it's going to feel very familiar to factoring because we're going to do a lot of that still. So we're basically solving equations by factoring is another way to say this. Now, before I get into how exactly we do that, it's important that we understand what a quadratic equation is. And I'll start with this right here. This is what we're familiar with. This is called a quadratic polynomial. This is what we saw when we began factoring. So they're polynomials written in the form ax squared plus bx plus c. For example, we have x squared minus 5x plus 4. This is written in this standard form. This is a quadratic polynomial. And one thing that all quadratics have in common is that their highest exponent is 2. So always look for that. If there's anything higher, like x to the third, there's a term for that that's different, but it's not what we're studying this week. We're focusing only on polynomials or equations where they have an exponent of 2. In other words, things that are being squared. Now, what a quadratic equation is really just taking this concept, just taking this and setting it equal to y. So you'll think back to what we did with slope-intercept, right? When we had like y equals mx plus b. That's how you would describe the graph of a line. Every linear graph or straight line follows this format, y equals mx plus b. Well, every quadratic graph, and I'm going to show you one here in just a second, follows this format where it's y equals x squared plus x minus 12. Or it could be anything. Y equals, could be this one here, y equals x squared minus 5x plus 4. But basically, you're just taking this same format and setting it equal to y. You're creating a function, essentially, is what you're doing. Now, whenever you're looking at quadratic graphs, they always have a shape that follows this general pattern here. It's sort of like this bowl shape. It's called a parabola, and here are a bunch of them for you to feast your eyes on. These are just random graphs of quadratic equations, and they vary in their size. So some are narrow, some are really wide open. Some of them face up, and then some of them face down. It's like this one here. But you see, here's the format again. Y equals ax squared plus bx plus c. Here's that universal format. And you don't really have to know much beyond that for today. We're not going to be graphing. But what is important is understanding the general shape and also understanding what we mean by solving, because here's what we're going to be doing today. The solutions to a quadratic equation, what we're looking for when we solve it, are the x-intercepts. That's what we're looking for. We're trying to find, okay, where does this graph cross the y-axis? Now you can see with this example here, which we're going to look at again later, it has a y-intercept of -4 and +3. It has two x-intercepts, not y-intercepts. Two x-intercepts. It crosses the x-axis at -4 and it crosses at 3. So this is what we mean by the solutions when we're trying to solve a quadratic equation. Now, for right now, I'm going to show you two examples of how to solve one. So here's one. It says find the solutions, in other words, the x-intercepts, there's a typo here, should be x-intercepts, to each quadratic equation. We'll start with this one, y equals x squared minus 3x minus 10. Now, in order to solve this, the first thing I have to do is factor it, because I have to find out, okay, where are these x-intercepts? There's going to be several of them, right? So where does this curvy parabola graph hit the x-axis? Well, the first thing I do is I factor, right? So I say, okay, y is equal to, and now this is, okay, pretty easy here. We're looking for factors of -10 that have a sum of -3. So I think that's going to be -5 and 2, right? Because -5 times 2 is -10. -5 plus 2 is -3. So there we go. So y equals x minus 5 times x plus 2. Now, the other thing to consider here is we can actually substitute another number in here. When we're talking about an x-intercept, right, just think about that conceptually. Whenever a graph crosses the x-axis, like here, or here, or here, what is its y value? What is y equal to every single time when we're dealing with an x-intercept? It could be either these, it could be these. Well, the answer is 0. In every single case, whenever we're looking at an x-intercept, we're looking for the x value when y is equal to 0. So that means I set this equal to 0. So I say 0 is equal to x minus 5 times x plus 2. And now we just have to ask ourselves, okay, well, what can x be in order to give me 0? Now, this requires an understanding of the multiplicative property of 0, right? So if I have something like this, either one of these, I have two numbers here, two values. I have an x minus 5 value and an x plus 2 value. Well, if just one of these is equal to 0, then this equation balances. Because if this were like, if I have this equation over here, right? If I say 0 is equal to AB, well, any number times 0 is 0. So if A is equal to 0, then this whole thing is 0. If B is equal to 0, then this whole thing is 0. So to solve this, I just have to set each of these parts equal to 0. I say, okay, well, x minus 5 equals 0, and x plus 2 equals 0. So I just have to find out what these x's must be in order to get these equal to 0. Okay, and from here you have a pretty simple equation to solve. I add 5 to both sides, I get x equals 5. I subtract 2 from both sides, I get x equals negative 2. So the solutions to this quadratic equation, and usually they put them in like this fancy looking bracket here, I would say that the domain, or the x-intercepts for this, are negative 2 and 5. So just to review here, because this is the only example I'm going to do with you for now, this is a quadratic equation. It's written in this format that has a quadratic polynomial equal to y. We solve it by factoring and by setting y equal to 0, because we're looking for those x-intercepts. And then we take each of these, since either of these can equal 0, I take each of these, set them equal to 0, and then solve for x. And those solutions represent our x-intercepts. These right here, these 2 points, are where this quadratic equation crosses the x-axis. And that's what we're going to be doing a lot of today.